Today we are going to start our unit on triangles. Now we'll actually be dealing with triangles for the next 3 units or so, but this first unit is really just getting into some properties of triangles and then some congruent triangles, and that's where we'll go. So to start off with, remember, a triangle is a polygon with 3 sides and 3 angles. Triangle. And we have several different types of triangles. They are classified either by their angles or by their sides. And most of these should be familiar to you. This first part is not anything new. But you can have an acute triangle to where all 3 angles are less than 90 degrees, so they're all acute angles. You can have an obtuse triangle where one angle is greater than 90 degrees. And you can only have one angle that's greater, not 2. And then we have right triangles, to where one angle is 90 degrees. And remember, we indicate that with the little box. That means those 2 sides are perpendicular, and the definition of perpendicular is that they form right angles. So those are the 3 ways to identify or classify a triangle based on its angles. According to its sides, we can have we'll start with a scalene triangle, and that is no congruent sides. So all 3 sides are congruent. And when we look at a triangle, if it doesn't have any congruent marks, or we're not told sides are congruent, then we know it's scalene. The next triangle is isosceles, and isosceles has at least 2 congruent sides. Now we say at least 2 because technically, if all 3 sides are congruent, it could be an isosceles triangle also. And so when we draw a triangle, if it's isosceles, we have 2 sides that are just marked congruent, or we're given a statement that says 2 of them are congruent. And finally, we have an equilateral triangle. And that's when all 3 sides are congruent. And to draw that, we draw our triangle, and we have to mark or have a statement saying that all 3 sides are congruent. And like I said, all of this information so far should not be new to you. Now we'll get into some stuff that is new to you. The isosceles triangle theorem tells us that the base angles of an isosceles triangle are congruent. So if we've got this isosceles triangle over here, these 2 angles are called the base angles. They're the angles formed by one of the congruent sides and the not congruent side. So that bottom side in that picture, this one here, that's not congruent. So these 2 form a base angle, and then these 2 form a base angle. And the isosceles triangle theorem tells us that those base angles are congruent. So if we were to label this A, B, C, because we know, or if we know that AB is congruent to AC, then we would know that angle B is congruent to angle C. That's the isosceles triangle theorem. If you can't remember the name of it, you can just say base angles of an isosceles triangle are congruent. Now the converse of that, remember converse says we're doing it backwards, and it tells us it requires a little bit more words. I'm going to do it in green just so they don't run together. In a triangle, if two angles are congruent, then the sides opposite those angles are congruent. So if we have this triangle here and we know, we'll call this one DEF, if we know that angle D and angle, angle E and angle F are congruent, then this tells us that DE and DF, those sides are also congruent. So one of them says if we have two angles, we know the sides are congruent. One of them says if we have two sides, we know the angles are congruent. So they're the same idea forwards and backwards. So using that concept, all right, for example 1, we want to find x. We know that these two sides are congruent. That means that these two angles have to be congruent. Make that a little more of an arc. So if they're congruent, what is the measure of this angle? Well, we don't know, but we know it's the same as the x, so we'll call it x. So now we've got something in for all three angles, and what do the three angles of a triangle add up to? They add up to 180. So we can say x plus 46 equals 180. Combine like terms, 2x plus 46 equals 180. We'll subtract 46 from both sides, so 2x equals 134, and we'll divide by 2, so x is 67. So we know each of those two angles are 67 degrees. If you wanted to check your work, what is 67 plus 67 plus 46? It's 180, so we know we did it right. For 1b, again, we've got two sides that are congruent, so we know these two angles are congruent. But this time we do have a measure for one of those angles, so we know both of them are 65 degrees. So we can say x plus 65 equals 180. So x plus 130 equals 180. Subtract 130, so our missing angle we know is 50 degrees. For example 2, because we've got these angles that we know are congruent, then we know the sides opposite those angles are congruent. So if you were to draw a ray out of the middle of our angle, the side that it intersects is the one that is opposite that. So we know that this x plus 22 is congruent to this 10. And what do we do with congruent things? Okay, if they're congruent, we know they're identical, same size, same shape. But that also means we can set their measurements equal to each other. So in this case, that gives us x plus 22 equals 10. Subtract 22 from both sides. So x equals negative 12. Now, it is okay for x to be negative as long as when we plug it back in, we don't get a negative number. So we couldn't have gotten x equals negative 30 because negative 30 plus 22 would still be negative. But this one works because when we plug it in, we do get a positive. For 2b, we have really the same exact setup. We've got two angles, so we know the two sides are congruent. So we can do 11 equals x plus 17. Subtract 17 from both sides, and negative 6 equals x. And again, it's okay for x to be negative as long as we plug it in to get a positive. Now, some other theorems and things that we need to discuss. The Equilateral Triangle theorem tells us that an equilateral triangle is equiangular. And that may be a new word for you. Equilateral means all the sides are the same. Equiangular means all the angles are the same. We're not going to go through and prove this, but it basically uses that isosceles triangle theorem. You have it with two sides up as congruent sides, but then when you turn the triangle, you end up with a different pair of congruent sides. So you're able to show all the sides are the same and all the angles are the same. And another thing, this isn't really a theorem in and of itself, but if all the angles are the same, and we know they have to add up to 180, then we have x plus x plus x equals 180, so 3x equals 180. So we know that all of those angles are going to be 60 degrees in an equilateral triangle. Always, doesn't matter how big it is, if it's equilateral, each angle is 60 degrees. The converse of that theorem, remember, converse is backwards, okay? And it just says an equiangular triangle is equilateral. So if we know all the angles are the same, then we also know all the sides are the same. If we know all the sides are the same, we also know all of the angles are the same. Okay, a couple definitions. Congruent figures, and I just mentioned this, two figures that have the same size and same shape. Same size and same shape. So if we were to put them on top of each other, then they would match up perfectly. Now, one of them could be flipped over, they could be rotated, they could be spun around and stuff, but there would be a way to flip them and move them around so that they line up on top of each other. Corresponding parts are the congruent pieces of congruent figures. So if I have two congruent figures, and let's say angle A and angle F are congruent to each other, they're from two different triangles, then we know those would be corresponding parts because they are the same. They're congruent. All right, now, for example 3, we're going to mark the corresponding parts of these congruent triangles. This statement right here, I'm going to write, okay, anytime you see a statement like this is a congruency statement. And it tells us which two triangles are congruent. Remember, we could name a triangle in several different ways, but when we're making a congruency statement or reading one, there's usually only one way that will work, that is true. And so in our congruency statement, the pieces have to be in the right order, so that whatever the first letter is in the first triangle, that corresponds to the first letter of the second triangle. As we work through this, hopefully this will make a little bit more sense. All right, so in example 3A, we've got a W first. Okay, so let's put our congruency mark there. Well, what is first in the other triangle? That's a J. So we know that W and J are congruent to each other. What's next? We've got X. Okay, and we're putting two arcs on X because it's not congruent to W, so it needs an extra mark. On the other triangle, that goes with K. So K gets 2 marks. And then finally, we only have one angle in each triangle left. Okay, so Y and L have to be congruent also. Now, just doing the angles is not enough to show all of our corresponding parts. We have 6 corresponding parts, 3 sides and 3 angles. So when we look at our sides, okay, we look at the first 2 letters, WX. That's going to be this side down here, and it corresponds to JK. So we've got 1 hash mark on JK. XY, that gets 2 hash marks. It corresponds to KL. So that one gets 2 hash marks. And then finally, this is the one that you have to work a little bit for. It's the first and last letter of the triangle. So WY goes with JL. So there we just marked all 3 of our sides congruent. We've done all 3 of our angles, so we got all 6 parts. If you didn't do 6 parts, you haven't finished the problem. For example 3B, we start with S. Okay, angle S corresponds to angle F. Angle R corresponds to angle E. And then angle Q corresponds to the other angle Q. Now, even technically we shouldn't call this angle Q because there's multiple angles there. But if we looked at the triangles separately, that's how it would be. Then we've got SR goes with FE. RQ goes with EQ. And then SQ goes with FQ. All right, for example 4, I forgot to write the directions in here. We're going to write a similarity statement for each of these 2. So for the first triangle, we can really name it in any order we want. And then the second triangle, we just have to match to that. I like to go in the order of the angles. So for my first triangle, D has 1 mark, F has 2 marks, and E has 3 marks. And so for my second triangle, I just have to figure out which one has 1 mark, which one has 2, which one has 3. So E has 1 mark, C has 2 marks, and B has 3 marks. So triangle DFE is congruent to triangle ECB. And notice in front of these, I'm putting the triangle symbol. The symbol for a triangle is a triangle. So if I didn't have that there, let's say that wasn't there, first of all, DFE doesn't refer to anything. I don't know if that's a plane or an angle or a triangle. It could be any of those because it's not labeled. So we need to make sure we put our appropriate labels there. For B, R has 1 mark, Q has 2 marks, and S has 3 marks. On the other triangle, Y has 1 mark, S has 2 marks, and W has 3 marks. Notice that even though S is part of both triangles, it doesn't correspond with itself. Because on this side it has 3 marks, on that side it has 2 marks. So just because the same letter is used in both doesn't mean it corresponds to itself. Be careful with that. And for these last 2, we want to find the or name the corresponding part. I think I left the directions off of these 2 so that it would fit on the page, because otherwise it kicked it to a new page. So we see here we've got GH, that's going to be this segment here, and it has 2 hash marks. So which side in the other triangle has 2 marks? Well, XZ does. Okay, it's a segment, so we put that segment over it. So GH is congruent to XZ. Now, if we didn't have the picture, we could still solve this. GH are the second and third letters in the name of our triangle. So XZ, the second and third letters in the other triangle, has to be the same, the corresponding side. And then for 5B, we've got ML. That's this one. It's got 2 hash marks. So 2 hash marks on the other one is LT. And again, ML and LT. So we can just use the name if we wanted to, even if we don't have a picture. So that's it for our introduction to triangles and congruent figures. So make sure you do those practice problems, ask questions as you need them, get ready for your mastery check. Good luck.